Good afternoon, students. Welcome back to chemistry class. Today we are going to study about how the electrons are filled in the atomic orbitals. How electrons are filling in atomic orbitals, that is filling of orbitals. In the previous section, I told about the energies of atomic orbitals and how the n plus L value designed and which orbitals has lower energy and which orbitals has higher energy. That's all about in last class we discussed. Today we are going to study about how the electrons are filled in various orbitals according to Alpha principle, Paulie's exclusion principle and Hund's rule. Very important. Alpha principle, Paulie exclusion principle and Hund's rule. Very important. Listen carefully. Okay. So what do you mean by Alpha principle? Alpha principle. The word Alpha in German means building up. The Alpha means building up. It states that in the ground state of the atoms, the orbitals are filled in the order of their increasing energies. Okay, in the ground state of the atoms. What do you mean by ground state? Ground state means without we are giving the energy, external energy, the orbital will not go to the higher orbital. Okay, for example, hydrogen atom, hydrogen atomic number 1, electronic configuration 1s1. So hydrogen atom always, the electron of the hydrogen atom always stay in the 1s orbital only without applying the any external energy. Okay, that is called the ground state. Okay, if you are applying any external energy, magnetic field or electric field, it will go to the higher energy state. Okay, so ground state means the lower energy state. In the ground state of the atoms, the orbitals are filled in the order of their increasing energies. That is, the electrons first occupy the lowest energy orbital. Okay, once the lower energy orbitals are completely filled, then the electrons enter the next higher energy orbitals. Once the lower energy orbitals are completely filled, then the electrons enter the next higher energy orbitals. For example, I am taking the carbon atomic number 6, electronic configuration. How do you write? 1s2, 2s2 and 2p2. Okay, totally 6 electrons. Okay, so first the electrons, the s orbital, totally 2 electrons, maximum electron, 2 electron we can accommodated. Okay, s orbital. So after the filling 2s orbital, okay, 1s2, after filling the 1s2 orbital, then it go to the 2s2 orbital, okay. After completing the 2s orbital, we can accommodate 2 electrons, okay. After completing the 2s orbital, then it will go to the 2p orbital. Okay, understood? This is the Alpha principle. In the ground state of the atoms, the orbitals are filled in the order of their increasing energies. Once the lower energy orbitals are completely filled, then the electrons enter the higher energy orbitals. Okay. Now I am going to draw the diagram based on the Alpha principle. How will you write how will you filling the orbitals according to Alpha principle? First of all, know the 4 quantum numbers about the principal quantum number and azimuthal quantum number about clearly. The principal quantum number n is equal to 1 means what is the L value? L is equal to 0. Okay, how will you get the azimuthal quantum number L? We can write 0 to n minus 1. Okay, 0 to n minus 1. So here 0, n value 1 means 1 minus 1, we get the 0. Okay, so n value 1 means L value 0. Okay, then so we can write this 0, L value 0, it indicates the s orbital. L value 1, it indicates the p orbital. L value 2, it indicates the d orbital. L value 3, it indicates the f orbital. Understood? So first upon n is equal to 1, L is equal to 0. So what is the orbital here? 1, yes. Okay. Principal quantum number 1, azimuthal quantum number 0. So what is the orbital name? 1, yes. Okay. Then n is equal to 2. N is equal to 2 means what is the L value? 0 and 1. Okay, start 0 to n minus 1. Here n value 2. So 2 minus 1 we get the 1. So 0 and 1. What is the orbital name? Here principal quantum number 2. So we L value 0, n value 2, L value 0. So we can write 2s. And n value 2, L value 1, we can write 2p. Okay. Then n is equal to 3. N is equal to 3 means what is the L value? L value we can write 0, 1, 2. Okay, 0, 2. N minus 1, here n value 3, 3 minus 1, 2. So we can write 0 to 2. Okay, 0, 1 and 2. Okay, so what is the orbital name here? N is equal to 3 means 3. L is equal to 0 means 3. Yes, okay, 3s. And n is equal to 3. L is equal to 1 means 3p. N is equal to 3. L is equal to 2 means 3d. Okay, 3d. After that, n is equal to 4. N is equal to 4 means how much L value we get? 0, 1, 2, 3. Okay, so what is the orbital name? N is equal to 4 and L is equal to 0 means 4s. N is equal to 1, N is equal to 4, L is equal to 1 means 4p. N is equal to 4, L is equal to 2 means 4d. N is equal to 4, L is equal to 3 means 4f. Okay. After that, n is equal to 5. N is equal to 5. N is equal to 5 means what is the L value? 0, 1, 2, 3 and 4. Up to 4 we can write. Okay. So here n is equal to 5. L is equal to 0 means 5s. N is equal to 5. L is equal to 1 means 5p. N is equal to 5. L is equal to 2 means 5d. N is equal to 5. L is equal to 3 means 5f. N is equal to 5. L is equal to 4 means 5g. Okay. But we no need to write the 5g orbital. Okay. The reason I will tell now. And then 6. N is equal to 6 means what are the L value? 0, 1, 2, 3, 4 and 5. Up to 5 we can write. Okay, but we can write 1, 2 and 3. Okay, so what is the n is equal to 6 and L is equal to 0 means 6s. N is equal to 6, L is equal to 1 means 6p. N is equal to 6, L is equal to 2 means 6d. Okay, after that n value 7. When n value 7, L value we can write 0 to 7. 0 to 6, up to 6 we can write. Okay, but here we can write, we write now only 0 and 1. Okay, so what is the n is equal to 7 means L is equal to 0 means 7, yes. N is equal to 7, L is equal to 1 means 7p. Okay. Why we write here? Eliminate some orbitals. What is the orbitals? 5g orbitals we didn't write now. 6 F and 6d orbital, 6g orbital we didn't write now, and 7d and 7f and 7g etc. we didn't write now. Why? What is the reason? Because all the elements that have known to scientists today can be accommodated in just these orbitals only. Okay, we totally 118 elements are discovered right now. So all the 118 elements we can write these orbitals only. Okay, so you should write these orbitals only. Okay, understood? And then how the orbitals arranging according to alpha principle. You know alpha principle, the ground state of the atoms, the orbitals are filled in the order of their increasing energies. Okay, increasing energies. So it is based on n plus L rule. Okay, the based on n plus L rule. What is n plus L rule? What do you mean by n plus L rule? It states that the lower the value of n plus L for an orbital, the lower is its energy. Okay, here which one is the lower energy? Lower the n plus L value. We already studied about the n plus L value. These are the order of the n plus L value. Okay, increasing order of the n plus L value. Yesterday, previous class, we studied clearly that. Okay, the lower the value of n plus L for an orbital, the lower is its energy. If two orbitals have the same value of n plus L, the orbital with the lower value of n will have the lower energy. Okay, n plus L value, suppose the same value, we get same value, we consider the n value. Which one is the lower n value? That is the lower energy orbital. Okay, depending upon the n plus L value, this is the increasing order of their energies of the orbitals. Okay, so first we can write oneness. We can you can trace the line. When you trace the line, you come to know how the electrons are filled in lowest energy orbital. This is a easy way to remember. Okay, easy way to remember, memorize this easy way. Okay, first we can trace the line oneness. Okay, after that you make the arrow mark, the downward arrow mark, make it here. Okay, first oneness. After that we can trace the 2s orbital, 2s. After that 2p and 3s orbital. After that 3p and 4s orbital. Okay, according to n plus L rule. After that 4s we can write the 3d. You can cut the 3d and 4p and 3d, 4p and 5s. Okay, after that 4d, 4p, 6x. Okay, after that 4f, 5d, 6p, 7s. Okay, after that 5f, 6d, 7p. Up to here we can mark. Okay, understood? So here in this diagram, all the arrows pointing downwards. Okay, downwards. You can know the direction of the orbital. Okay, this is the diagram for the alpha principle, lower energy orbitals. Okay, according to this concept, we can write the electronic configuration. We can fill the electrons in the atomic orbitals. Okay, already previous sections I explained about that alpha principle. Just will recall that. First oneness orbital, first electrons filled in the oneness orbital. After that 2s, after that 2p, after that 3s, and then 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. This order we can fill the electrons. Okay, s orbital, you know, total maximum 2 electrons we can accommodate it in s orbital. P orbital we can accommodate maximum 6 electron, and d orbital maximum 10 electron we can accommodate it, and f orbital maximum 14 electron we can accommodate it. Understood? So if you know not having the book, you can now note this concept. You can note it, the alpha principle definition and the diagram. Okay, students, then we are going to study about Paulie exclusion principle. Paulie's exclusion principle, it states that no two electrons in an atom can have the same set of values of all four quantum numbers. Okay, the Paulie exclusion principle, very important question, 3-mark question. No two electrons in an atom can have the same set of values of all four quantum numbers. It means that each electron must have unique values for the four quantum numbers. Okay, what are the four quantum numbers? Principal quantum numbers, azimuthal quantum numbers, magnetic quantum number, and the spin quantum number. Okay, N, L, M, and S. Okay, here principal quantum number tells us about the shells. Okay, shells or orbits. Azimuthal quantum number tells us about the subshells. What are the subshells? S subshell, P subshell, D subshell, F subshell. Okay, and magnetic quantum number tells us about the orbitals, whether it is px, py, pz, or dxy, dxz, dyz, or any of the d orbitals. Okay, so magnetic quantum number tells about the orbitals. Okay, and spin quantum number, it explains about the orientation of electrons in an orbital. Okay, each orbital we can accommodate 2 electrons. Okay, if the 2 electrons in orbitals, one has the positive spin and another one has the negative spin. Okay, so the Paulie's exclusion principle, it suggests that no 2 electrons in an atom can have the same set of values of all four quantum numbers. Okay, no two electrons in an atom can have the same set of values of all four quantum numbers. It means that each electron must have unique value. Okay, for the four quantum numbers. Suppose even it have same set values of first 3 quantum numbers, the fourth quantum number about the spin quantum number has to be different. Okay, the spin quantum number, one of the electron is positive spin, another one of the electron has negative spin. Okay, one is the up spin and one is the down spin. That is, one is clockwise and another one is clockwise direction, anti-clockwise direction. Okay, so the Paulie exclusion states that every electron in an atom are exclusive. Okay, every electrons in an atom are exclusive. That is why we called Paulie exclusion principle. Okay, so Paulie exclusion principle means no 2 electrons in an atom can have the same set of values of all four quantum numbers. Okay, so each electron must have unique value for the four quantum numbers. For example, the one electron present in hydrogen atom, you know, only one electron. Okay, let us write the four quantum numbers of the one electron for in the hydrogen atom. We can write the four quantum numbers. So hydrogen atom, only one electron. Here n value, what is the n value? Principal quantum number, it tells about the orbits. Okay, so one electron is present in the first orbit means n is equal to 1. Okay, n is equal to 1 means what is the L value? We can write 1 minus n minus 1, that is 1 minus 1 is equal to 0. Okay, L value 0, means m value 0. Okay, and what is the spin here, which is the orbital? 1s1 orbital. Okay, 1s1 orbital, only one s orbital, only one orientation. Here only one electron is present in the s orbital, so we can write this. Okay, this means it is positive spin plus half. Okay, the value of spin, it is plus half. Okay, for the 2 electrons present in helium, for the 2 electron present in helium. Helium atom, you know atomic number 2. So atomic number 2 means how many electrons are present? 2 electrons. Okay. So 2 electrons present in an helium atom. The each of the electron, the one electron has the quantum number same as the electrons of hydrogen atom. N is equal to 1. L is equal to 0, M is equal to 0 and S is equal to minus plus half. Okay, helium atom 2 electrons. Here electronic configuration 1s2. So 1 electron, it is 1s orbital, it is present in the electron. It is in clockwise. Okay, so n value, it is present in first orbit. First orbit means k. K means n is equal to 1. Okay, and the n value 1 means L value 0, you know. L value 0 means M value 0. Okay, for the 2 electrons, the first 3 quantum numbers are same. First 3 quantum numbers are same. First electron and the second electron. Okay, and the spin quantum number here different. Okay, here spin quantum number for hydrogen atom, first electron, N is equal to 1, L is equal to 0, M is equal to 0 and S is equal to plus half. And the second, another one electron having this second electron also, N is equal to 1, L is equal to 0, M is equal to 0 and S value, it is anti-clockwise in direction. Okay, S value minus half. Understood? As we know that spin quantum number can have only 2 values. What are the 2 values? Plus half and minus half. Okay. Only 2 electrons can be accommodated in a given orbital in accordance with the Paulie exclusion principle. Okay. So what is the Paulie exclusion principle? It states that no 2 electrons in an atom can have the same set of values of all 4 quantum numbers. Okay, I just explain with an example. I take the neon for the example here. Neon, what is the atomic number? Neon 10. Atomic number 10. What is the electronic configuration? 1s2, 2s2 and 2p6. Okay, 1s2 means first orbit, first shell, that is K shell. K shell we can accommodate 2 electron. Okay, N is equal to 1. So first 1s2 means 2 electron. We can write separately the quantum numbers value. We can write separately. The first N is equal to 1. N is equal to 1. L is equal to 0. M is equal to 0. And S value plus half. Okay, plus half. And second electron, N is equal to 1, same. Okay, L is equal to 0, M is equal to 0, but S value only differ here. S value minus half. It is present in anti-clockwise direction. Okay, then all the 4 quantum numbers, now I am writing all the 4 quantum numbers for the 8 electrons in L shell. Okay, here 1s2, this is N is equal to 1. Then second shell we can accommodate 8 electrons. That is which shell? L shell. Okay, L shell. Second shell we known as L shell. L shell totally we can accommodate 8 electrons. We can accommodate it. Okay, 2s2, 2p6. Totally 8 electrons. How can you write all the 4 quantum numbers of these 8 electrons? Okay, listen here. First electron, totally 8 electron. Now we are going to write all the 4 quantum numbers of second L shell, 8 electrons. Okay, L shell 8 electrons we can write now. Electrons, first electron, second electron, third electron, fourth electron, fifth electron, sixth electron, seventh electron and 8th electron. What is the N value? What is the N value here? What is the N value? N is equal to, here which shell the electrons are occupied? Second shell. Okay, N shell. N shell, second shell means L shell. L shell, there is the N value The first shell means n is equal to 1. Second shell means n is equal to 2. Okay, so all the electrons, all the 8 electrons, n value 2. Okay, so all the electrons we can write the n value 2, 2, 2, 2, 2, 2, 2, 2. Okay, then what is the L value? What is the L value? Here we can write L value when n is equal to 2. N is equal to 2 means here first we can write 0. Okay, first shell, first orbital, yes, it indicate the, yes, okay, 2s2 and 2p6. Okay, here 2s2, the s orbital we can accommodate 2 electrons. So L value for s, L value 0. Okay, how many electrons? 2. For first 2 electrons, L value 0, 0, 0. And 2p6. Okay, all the other electrons are p orbital. P orbital, what is the L value? 1. Okay, p orbital, what is the L value? 1. So all the 6 electron we can write 1. Okay, p for the p orbital means L value 1. You know. Okay, 1, 1, 1, 1, 1, 1. Okay, and then we are going to write the m value. Okay, m value. So here L is equal to 0, you know, L is equal to 0 means what is the m value? 0. Here also 0. Okay, and then here 6p orbital, 6p orbital, L is equal to 1 means what is the m value? Minus 1, 0, plus 1. Okay, L is equal to 0, 1 means what is the m value? M value we can write minus L through minus L2 plus L through 0. Okay, so we can write minus L, 1, L value 1. So we can write first 3 L values, we can write minus 1, 0, plus 1. Another 3 L value, we can write minus 1, 0, plus 1. Okay, these are the m value. And then what is the s value? S value, first, you know, 2s2 orbital, 2 electron we can accommodate in s orbital. One is clockwise. Clockwise means plus half. Another electron is anti-clockwise. Okay, so the p orbital, when we are writing the p, or when we are filling the electrons in the p orbital totally we can accommodate 6 electron we can accommodate. Okay, 3 orbitals there. Each orbital we can accommodate 2 electrons. Okay, so first we can filling in syncly. Okay, so that is clockwise direction. 1, 2, 3. Okay, so what is this meaning? Clockwise means plus half. Okay, so first 3 electrons we can the s value we can write plus half. Okay, plus half, plus half, plus half. Okay, after that we can fill the minus half value. Minus half value means it is anti-clockwise direction. Okay, we can write like this. So m value minus half, minus half, minus half. Okay, this is the 4 quantum numbers values. 4 quantum numbers values for the 8 electrons in the L shell. Understood now? So you see here all the electrons, each electrons. Okay, each electrons have the unique quantum number value. Okay, the value each electrons have the unique value for the 4 quantum number. Okay, each electron have the unique value for the 4 quantum numbers. These are the Paulie's exclusion principle. What do you mean by Pauli exclusion principle? No 2 electrons in an atom can have the same set of values. Okay, this is the s orbital, this is the 2 electrons for the s orbital. Okay, here these 2 electrons for the first 3 quantum numbers same value. Okay, same value, but spin quantum number differ. Okay, and another here see, listen here, 3rd, 4th electron principal quantum number same value. For the 3 electrons, principal quantum number same value, and azimuthal quantum number also same value. And next 6 electrons, principal quantum number and azimuthal quantum number also same value. Okay, and then magnetic quantum number differ. Okay, each electron's magnetic quantum number and the spin quantum number also differ. Okay, these are about the Paulie exclusion principle. Understood? So no two electrons in an atom can have the same set of values of all four quantum numbers. Understood? I hope all of you understood. Then we are going to study about Hund's rule. What do you mean by Hund's rule? Hund's rule, it states that electron pairing in the degenerate orbitals does not take place until all the available orbitals contain one electron each. Okay, it states that electron pairing means pair up. Okay, pairing in the degenerate orbitals. What do you mean by degenerate? In previous class we studied about that. Degenerate means, if you take the P orbitals, how many possible orientations? There are three orientations. What are the three orientations? Px, Py, Pz. For the three P orbitals have the same energy. Okay, all the three P orbitals have the same energy. Okay, up to we are applying any external energy source. Okay, if we are giving any external energy source, the electrons move to the higher energy state. Okay, from the ground state it can be go to the higher energy state. Okay, so in the ground state all the P orbitals, otherwise D orbitals and F orbitals, P orbitals maximum three P orbitals having, D orbital, for D orbital 5 D orbitals are having, F orbital totally 7 F orbitals are having. Okay, so for the all the orbitals have the same energy, that is called degenerate orbitals. Okay, so it is the electron pairing in the degenerate orbitals does not take place until all the available orbitals contains one electron each. Okay, in the case of filling of orbitals with electrons of a multi-electron atom in each ground state, the subshell of every orbitals must be singly occupied before the double occupancy starts. Okay, all the electrons in single occupancy must have the same spin for the maximum of the total spin. Okay, let us understand this rule in a detailed manner. The electrons are filled in the sp, d and f orbitals of an atom. Each orbital has a specific capacity. The capacities of the orbitals are: s orbital, maximum we can accommodate 2 electrons. P orbital, we can accommodate maximum 6 electrons. D orbital, 10 electrons we can accommodate. F orbital, maximum 14 electrons we can accommodate. Okay, again in each orbitals of the subshell, that can contain a maximum 2 electrons. In s orbital maximum 2 electrons we can accommodate it. Okay, there is s orbital, for s subshell 3 orbitals, 1 orbital for the s subshell. Okay, s orbital totally only 1 orbital. For 3 orbital totally, p orbital totally 3 orbitals. For d orbital totally 5 orbitals. F orbital totally 7 orbitals. We know about that. When the electrons are filled in their orbitals, each of the orbitals is filled first with single electrons in the same spin. Okay, first you should fill the orbitals is first single. Okay, single electron with the same spin. Same spin means only clockwise. Okay, after filling all the orbitals of the same subshell, the electrons are filled for the double occupancy in each of the same subshell with the opposite spin. Okay, after filling all the orbitals of the same subshell, the electrons are filled for the double occupancy in each of the same subshell with the opposite spin. Okay, it is explained with an example. Okay, we know that there are 3 p orbitals, 5 d orbitals, 7 f orbitals. According to this rule, pairing of electrons in these orbitals starts only when the 4th, 6th and 8th electron enters the p, d and f orbitals respectively. Okay, the pairing takes place only for p orbital. It starts from 4th orbital. Okay, for example, this is the p orbital. This is the p orbital. Total how many p orbitals are there? 3 p orbital. Px, py, pz. Okay, when the pairing takes place, pairing of electrons when takes place, we can start from here 1 electron, 2 electron, 3 electron. Okay, 3 electron we can fill in clockwise direction, same spin. After that, on 4th electron onwards, okay, 4th electron onwards, we can, the pairing started. Okay, 4th electron onwards, pairing started. Understood? For example, consider the carbon atom. Consider the carbon atom which has 6 electrons. Carbon atomic number 6, 6 electrons are there. So what is the electronic configuration according to Alpha principle? 1s2, 2s2 and 2p2. It can be represented as this orbital, only one s orbital is there. Totally how many electrons? 2 electrons. Okay, first clockwise direction and then anti-clockwise direction. Second, 2s orbital, only one s orbital. How much electrons? 2 electrons. So first clockwise, after that anti-clockwise. And then p orbital, totally how much p orbitals there? 3 p orbitals. Okay, 2px, 2py and 2pz. Okay, total how much orbitals there? Only, how many electrons there? Only 2 electrons there. Okay, so how we can fill the 2 electrons in p orbital? We can fill with the same spin. These 2 electrons we can fill singly with the same spin. Okay, understood? This is the Hund's rule. For example, fluorine atomic number 9, what is the electronic configuration? 1s2, 2s2 and 2p5. Okay, 2p5, 1s orbital. This is 1s orbital, totally 2 electrons. 2s orbital, totally 2 electrons. And 2p orbital, totally how much electrons? 5 electrons. Total 3 orbitals there. 2px, 2py and 2pz. Okay, so totally 5 electrons. First you should fill singly. Okay, 1, 2, 3. Okay, from the 4th electron onwards we can fill doubly. Okay, with the opposite spin. Okay, so after the 4th electron we can fill with opposite spin. Okay, 4, 5. Okay, why we are filling like this? In order to minimize the electron repulsion. Okay, consider the carbon atom. The 6th electron enters the unoccupied 2py orbital as per the Hund's rule. Okay, the 6th electron 2, 4, 5 and 6th electron enters the unoccupied 2py orbital. Okay, as per the Hund's rule. This is the Hund's rule. It does not get paired with the 5th electron already present in the 2px orbital. It does not get paired because of the electron repulsion. Okay, what do you mean by Hund's rule? It states that electrons pairing in the degenerate orbitals does not take place until all the available orbitals contains 1 electron each. Okay, the electrons pairing in the degenerate orbitals does not take place. Okay, electron pairing does not take place in the degenerate orbital because this is the available orbital contain 1 electron each. Okay, Understood? These are about the Hund's rule. Okay, today assignment. These three principles very important. Alpha principle, Paulie exclusion principle, and Hund's rule very important. Okay, write the assignment now. Describe alpha principle and draw the diagram. Second question, state Paulie exclusion principle. Fourth question, define Hund's rule. Very important question. Okay, I will now mark in your book. If you are having book, take your book, page number 52 and 53. Students, take page number 52. Alpha principle. In the ground state of the atom, from this line onwards you have to mark. In the ground state of the atoms, the orbitals are filled in the order of their increasing energies. That is the electrons that first occupy the lowest energy orbital available to them. Once the lower energy orbital is completely filled, then the electrons enter the next higher energy orbital. Up to here you have to mark. Okay, and then I have to mark this diagram of a principal diagram. You have to mark 3 mark question, very important. Study well. And then Paulie exclusion principle, from second line onwards you have to mark. No two electrons in an atom can have the same set of values of all 4 quantum numbers. It means that each electron must have unique values for the 4 quantum numbers, that is n, l, m and s. For the lone electron present, lone means one electron present in hydrogen atom, the 4 quantum numbers are n is equal to 1, n is equal to 0, m is equal to 0 and s is equal to plus half. For the 2 electron present in helium, 1 electron has the quantum number same as the electrons of hydrogen atom, n is equal to 1, l is equal to 0, m is equal to 0 and s is equal to plus half. For other electron, the 4th quantum number is different. n is equal to 1, l is equal to 0, m is equal to 0 and s is equal to minus half. As we know that the spin quantum number can have only 2 values, plus half and minus half. Only 2 electrons can be accommodated in a given orbital in accordance with Paulie exclusion principle. Up to here you have to mark. Okay, after that Hund's rule. Hund's rule, the page number 53, from 8th line onwards you have to mark. It states that electron pairing in the degenerate orbitals does not take place until all the available orbitals contain 1 electron each. We know that there are 3 p orbitals, 5 d orbitals and 7 f orbitals. According to this rule, pairing of electrons in these orbitals starts only when the 4th, 6th and 8th electron enters the p, d and f orbitals respectively. For example, consider the carbon atom which has 6 electrons. According to the alpha principle, the electronic configuration is 1s2, 2s2, 2p2. It can be represented as follows. This orbital diagram also you should write. In this case, in order to minimize the electron repulsion, the 6th electron enters the unoccupied 2py orbital as per Hund's rule. That is, it does not get paired with the 5th electron already present in the 2px orbital. Up to here you have to mark. Very important. The 3 questions, very important for 3 mark questions. Study well and write and send me through WhatsApp. Okay, study assignment. Only very few students only sent me. This is my kindly I ask you, all of you should write the assignment and send me. Okay, thank you all of you.